Hello everyone. So in this video, let's continue our discussion on distributed SQL database. So if you haven't checked out my previous video, I highly recommend you to first go and watch out the introduction of distributed SQL databases and then come and watch this particular series. I will make a lot of different videos as well on techniques we'll follow when we have a distributed SQL databases. Don't worry. In this video, we'll talk about what are transaction and what are asset properties and why there is a problem of following asset properties when we have a distributed SQL data. Okay, so let's move down to the actual video without wasting it. So, what is a transaction actually? A transaction is a context of database. In a context of databases and computer system is a sequence of operations that are performed as a single logical unit of work. It has to be performed as a single logical unit of work. Okay, let's take some example before coming down and completing this definition. Let's say that you are doing a transition. Transition is generally a word when you heard it in terms of banking sector, that you are doing some transition. So transaction in simple terms also mean that this is a sequence of operations that you have to do in all or none manner. It has to be either done all these sequences or none at all. You cannot do partial operations. Okay, let's say you are doing some operations using some computer, there is some failure. If there is some failure, it should not happen that I just only perform these operations and these are some hot, like some sort of failed. That is not a valid transition. Okay, so you have to maintain that transition should be done in an all or none manner. Okay, so as you can see that in this example, let's say we are transferring money from account A to account B, 100 rupees or $100, whatever you want. Let's say in that particular transaction, when the transaction begins, you have to subtract it from account A and add it to account B. You cannot have done that. You just subtract it from account A and doesn't provide it to account B. That is an invalid transaction. So that is what a transaction is, that it is some sort of a logical statements, a logical operation that has to be done all or none. Okay? Let's move on to the definition again. That a transition in a context of databases and computer system is a sequence of operations performed as a single logical unit of work. A transition is designed to be atomic. Atomic means that, meaning it has to be either fully completed or fully fails. There is no intermediate state in a transition. Okay, this ensures consistency, reliability, and integrity in the system. We'll talk about these terms in half of this video, but it just ensures consistency. The data is consistent, reliable, that I'm assured that the data is particularly fine there, and it like integrated the system, like whatever is directed should be present here. So there is no discrepancy in the system. That's the complete logic of the particular definition of what a transition. Let's move forward. Whenever you hit or whenever you see transaction or when you're talking about SQL databases, you always heard about asset properties because SQL databases tend to follow asset properties when it is not distributed. Okay. Now, what is asset properties? This is a very, you can say, important question that has been asked in a lot of interviews as well. So stay tuned on this part. ACID is an acronym for atomicity, consistency, isolation, and durability. So let's talk about all of these four terms one by one with examples. So let's take an example that whenever you're doing a transaction in an SQL database, which is, let's say, not distributed for this particular case, it follows asset properties, which means that the transaction that is occurring in an SQL database has to be atomic. So atomic means that I've told you all or nothing. That either all the complete instruction has to be followed or nothing. The transition must be either complete entirely or not at all. If any part of the transaction fails, the entire transaction has to be rolled back and the system is left in the previous state. So, as you have told, SQL databases which are following transaction has to follow asset properties, that it should be atomic, that it should roll back if the transaction fails. As you can see that when you're transferring money from account B to account A, or let A to B, it should be either the transition should be completed, that it should be atomic, like it cannot happen that A deducted the money and B doesn't got. Then consistency made the transaction must transition the database from one valid state to another valid state, maintaining all defined rules and constraints. So consistency means that if in the previous state I have 100 rupees and you have 0 rupees, and if I've transferred you 100 rupees, now I should get 0 rupees and you should have 100 rupees. So data should be consistent. It should not happen that from air you produce $100, or from air the $100 has just vanished out. Okay, so there should be consistency among the data. Okay, if the bank's data required the sum of all the accounts, the sum of the accounts should be same. Okay, if I have given you money and you have received it, or you have received it and I have get it, the total money should remain same. Okay, that is the overall thing. So that is what consistency is. Isolation means that the transaction should operate independently of one another. It should not happen that I am doing a transaction of giving money to you, and at the same time another transaction again happen that you are, let's say, withdrawing money. So whenever I am doing a transaction, your account and my transaction should be in an isolated manner. No other transaction or action should be happened on our account, or whenever we have set of rules that should be followed, that should be followed in a like in a complete or none manner. So no other operation should be performed in the transaction when it is already going on. So it should be isolated from the other transactions that is performing, or other operations that are performing in the database, in terms of whenever we're talking about database transaction. The transition should be operating independently of each other. The intermediate states of a transition should not be visible to other transactions, ensuring that they do not interfere with each other. If one transaction or the two transactions are happening simultaneously, one reading the account and the other is updating, isolation ensure that the reading transaction won't affect the data that is updating it. Because if I'm reading and updating at the same time, these are two different transactions. They should be not interfering with each other, so that like the data consistency will be mattered. That I will, like, I'm doing some transaction, I'm getting out some money, and the other sees that there is already money, because there are two different transactions. So it should not happen. They should be happening in an isolated. Last thing is durable. That if, let's say, there is some system failure, okay, my transaction should be durable, right? It should persist there. It should not happen that if there's system failure, my data somehow should vanish out. Okay, once a transaction has been committed that it is completely done, its changes are permanent and must survive any subsequent system failure. System failure occurs and my transaction is done. System failures occurs after that. It should not happen that my system will revert to a previous state, or my money just, or the instruction that I've done is just vanished out. So that durable, the instructions that I've done in a transaction should be durable on the disk or whatever that I have done. Okay, so these are the four particular acronym, you can say, definitions, asset properties. You should remember that when you're talking about SQL database. But as I've told you, these all are followed when you have, let's say, a single instance. But let's say you have a distributed system. You have two different instances. One, let's say, and give you an example. Let's say one server you have, one database that you have of SQL. Okay, it has some data. Let's say data one. Okay, and then say, let's say you have another database of data two. Okay, both of them consist some part of the data, because I've done some sharding. Let's say I have SQL databases. Some part is stored here. Okay, some part is stored here and some part is stored here. Now I want to do, let's say, some transaction. So transaction means that some data has to be changed here, some has to be changed here. If there are multiple databases, some has to be changed here. Okay, the thing is that if there are multiple databases, transaction means that all has to be done or nothing has to be done. Let's say if I done changes in this, and somehow this database get down, then what should happen? Because database are all together different. One database you can manage asset properties, but when there are a lot of databases, then you have ensuring their distributedness, then it is difficult to maintain asset properties. Let's talk about the difficulties as well when you have to handle asset properties in a distributed. So why each asset property is difficult to maintain in a distributed system? Let's talk about each property once again. So let's say we'll talk about atomicity now. The challenge is that in a distributed system, ensuring that all the paths of the transactions either commit or roll back together across multiple nodes is different. Because if one part of the transaction fails, or the network partition, or let's say one of the part of the database get down, then you have to coordinate and do the rollback in all of them, which becomes a lot of complex thing. If you have one database, then it is fine. But if you have multiple databases, multiple nodes, then doing a rollback, doing a commit across all the nodes, it has become difficult to maintain this particular, like you can say, property. So as you can see, consider that a distributed transaction that involves updating record on three different servers. You have three different servers and you have to update in all of them. Okay, server means that let's say you understand that different databases only. Okay, so these servers are talking to different databases and all of them different, and you have to do it in a transaction. So like if the network fails after only two servers commit the transaction, two servers has done the changes, and then there's the third server, when it is doing the change, it just fails out. So the third server might left in inconsistent state. The third server doesn't have the data. It is in the previous data only because that is not committed. But the two other databases have committed. It has done the changes. So now there is inconsistency. Two databases had the thing that I have updated my table. The other one is not. So there is inconsistency. There is now money that is, or let's say there is some data that is inconsistent. That is the problem. Okay, the next is consistency. Again, in a distributed system, consistency required that all the nodes agree on the same state after the data is done with the transaction. But as I have told you, that if there is some network delay, there is some network partition, then all the thing is that there will be some consistency issue, because one of the database will ensure that, let's say in this database, A has money equal to 10, okay, and B has money equal to 20. Now this database is the replica, like the same replica of this database, because I have to maintain availability. So I have two databases which has the same data. Let's say again A has 10 and B has 20. Okay, now let's say I'm doing some transaction to update from A giving money to B. So now this become 5, this become 25. Let's say this has transferred 5 rupees from A to B. This become, but now when I have to update this to the other server, this becomes down, or this become network partition. There is some problem happening there. So now the inconsistency there. This database has updated that A has 5, B has 25, but this database again has A 10 and B 20, which means that there is some inconsistency in the data between two data servers, and thus that is difficult because you have two different servers. So now in this manner, when you have distributed nature, consistency maintaining in that property is difficult. Let's go to the next point. Let's say isolation. As you can see, achieving isolation in a distributed system means ensuring that transaction appears to be executed sequentially even when they're distributed across the multiple nodes. As you can see that when I'm doing isolation, which means that I have to ensure that whatever I'm doing, no other transaction should be affecting it. But now if there are multiple nodes, I have to ensure that other transactions should also be logged. Okay, let's say I'm doing a transaction on, I'm doing a transaction, let's say on the first server, the other server, the third server. Let's say there are hundreds of servers like this. The problem with all of this is, let's say I'm doing some transaction or some commit on this one, but this is not still not in the transaction state still now. But the other transactions come and take a lock on this particular rows. That is difficult because there is already a transaction that is going on, which will come in a sequential manner to this particular server as well. But another request come to this server first and take a lock or take some update on the particular row, and this transaction is coming, but there is obviously some delay in the network because there are a lot of different servers and causing a problem and inconsistency there as well. So this is a challenging because nodes must synchronize between the states changing without blocking each other. Because let's say they are changing the states, one is changing, again another is changing, but if I'm blocking, if I'm saying that if I'm updating this, all the database should be blocked because I'm doing some transaction. Now I have to ensure that all the database will be blocked before doing this. That is also not a good approach because in that manner the database will be blocked and I cannot do other operations on the databases. That is also bad. So I have to, like, this is also a problem when we are doing distributed transactions. Okay, isolation is also causing a problem. And the last problem, as you can see, is durability. Ensuring durability in a distributed system requires that the committed data is stored reliably across all the nodes. All the nodes has the same data. But again, if some data or some server goes down while committing, while the others are up, again there is an inconsistency. One server shows different data, another server shows different data, and the data is not durable in one of the servers. Another server has some data, inconsistencies there, data reliability is also there. That is a challenge. So these often required complex replication procedures among these different servers, which again increases the complexity of the problem, and like you can say the actual asset property is now hampered. Example taking, after a transaction is committed, all the nodes must store the results permanently. If one of the nodes fail while committing, but before the acknowledging, the system will ensure that the committed data is not lost. But as you can see, when I am committing and there is some acknowledgement that is going that I am doing some committing, but there is some data partition or the server goes down. In that say, let's say the data is not particularly durable on that system, and then there is some inconsistency. So these are the particular four problems that we can see that the asset properties are not properly followed when we are talking about distributed SQL database. So we talked about transition, asset properties, as well as what are the different challenges we faced when we do distributed SQL transactions. Okay. In the next video, we'll talk about how we can overcome these different challenges by doing distributed transactions. How we can do that, we'll talk about in the next video. Stay tuned on this particular video. Yes, I will see you in the next one. Till keep coding.